All right, Precalc, here we have it, the ambiguous case. So this is what happens if you look at this box that I provided. The most important thing that we need to see here is this right here. It says, notice that H is equal to little b times the sign of A. So we have to put this in. I'm going to work on this one problem in this example today. This is from example 5 in your notes from 6-1, and it tells us find two triangles. They're already letting us know, hey, the ambiguous case is happening. Not all the time do they tell us that. So let's plug in what we know. H is equal to 5 times the sine of A, and yes, you do want your calculator in angle degrees, and you also want to make sure you have your calculator with you. So H is equal to 5 times the sine of 58 degrees. So I worked this question out in advance. Notice that H is equal to 4.24. Now we have to look at what they tell us here. If A is less than H, well, A is 4.5, H is 4.24. That is not our case. We know that because it tells us already that we're doing 2. If A is equal or A is greater than B, well, in this case, A is not greater than B, nor is A equal. So we know there's not 1. And this one says if A is less than or equal to B, that could be it. But because of what we found out here, that H is less than A, which is less than B. H is less than A, which is less than B. I know that I have 2 triangles. Okay, we also know that A was not greater than B. Okay, typically and ideally we have 1 triangle and life is good. But in this case I have 2 triangles. So we have to understand what we have to do here. So the first thing we're going to do is find a triangle, the first triangle, the way that we always do. So I like to draw my triangles. Oh, before we do that, let's go ahead and look at the triangles and how this happens. Notice here that we could have one obtuse angle. Do y'all see the obtuse angle right here that I'm drawing in purple? That's one scenario. But the other triangle is like what we usually look at that I'm drawing in yellow. So this is what we're going to draw first, this regular triangle, and label everything we know. So I'm going to do the first one in purple. It's a regular triangle. I'm going to label A, B, and C. A is 58 degrees. Little a is 4.5. Little b is 5. And I know that A over the sine of A is equal to B over the sine of B. So let's cross multiply. 5 times the sine of B is equal to 4.5 times the sine of 58. All right, so when I divide this by 5, I end up with the sine of B is equal to 4.5 sine of 58 degrees all over 5, which tells me if I put this in my calculator, make sure you're using parentheses or push equals, it's 0.94227 ... Now, from here, I would just hit second, sine, second, answer, and you could throw that answer right in there. And we will notice that B is 70.43 degrees. So I know this B right here is 70.43 degrees. Now remember, this is only my first triangle. So if A is 58 degrees and B is 70.43 degrees, by using 180 minus A minus B, I can find out what C is. And good. C was 51 point, I just rounded to 6, so I actually took off this 3 right here. So we'll just keep it simple today. We'll just round 1 decimal place. So from here, I know that little a was 4.5 and little b was 5. Now I always stick with what I know. I use what I know to find out. So I'd go right back to what I know. The sign, because these are the ones that were given, so I would use those to find the rest. The sine, a, which is 4.5 over the sine of 58 is equal to c over the sine of 51.6. And when you cross multiply, you will get the answer to c. So good. For c, you should get 4.16. Now, the unfortunate news is this is just the answer to the first triangle. So remember, we did the triangle in the yellow first. So we did the normal acute triangle, but now we have to deal with this purple one that I made for you because this purple one is an obtuse angle. Do you see this obtuse angle? So now I'm going to redraw and show you how to do that from here. So I'm going to redraw it over here. I know I have an obtuse triangle, and I'm probably not doing a very great job redrawing it. But I know that A was 58 degrees. And we also know if I called this B and called this C, this may not be drawn to proportion. This is 5 and this is 4.5. But because when I found the B angle originally, remember that B angle was 70.4. So I'm going to go back over here now that we're working with the second triangle. To get the obtuse angle for the B angle, I have to take 180 minus 70.4 to get the new B angle. So that ends up becoming 109.6 degrees. I'll write that right in here, 109.6 degrees. From there, we could go ahead and find the C angle. Remember that all angles in a triangle add up to be 180 degrees. So I'm going to go ahead and find the C angle. Well, I'm going to take 109 and add it to 58 and subtract that number from 180, and I get 12.4 degrees. So now this is what we're working with, guys. I'm going to use the law of sines to find the rest. 4.5 over the sine of 58 is equal to, well, we know this is 12.4. So I'm going to put C over, oops, I forgot the sign. The sine of 12.4 degrees. Again, calculator has to be in degrees. We want to cross multiply. You could literally take sine of 12.4 times 4.5 and then divide by 58. And what did y'all get for C? Little c was 1.139. So remember, everything else was the same. Little a was still 4.5. Little b was still 5. But now because of the new triangle, we have a smaller angle. We're making that smaller angle because this became the obtuse angle. So please just be aware of how to do this. I would never make you do this without this information. For any test, even if we were in school right now, I would give you the ambiguous case because it is a little bit more difficult. I have actually not seen the ambiguous case on an SAT, so tell me if I'm wrong and if you have seen it. I've seen the law of sines, but I don't think I've specifically seen the ambiguous case. All right, so we do have 2 answers. The first one is boxed in pink. My second one I will box in pink as well. And the question said, find 2 triangles. We found them. Great job, guys.